Hello everyone, how is it going? Welcome back to this series where we build an entity component system performant from scratch. Last time, in my previous video, I gave a very high-level introduction to the series. I explained what is an entity component system. Now, in this video, we're going to be doing architecture. We're going to be trying to come up with an architecture for this entity component system. So what I find useful for doing this is to start with requirements. Okay, let me switch to my tablet. So we want to essentially list some requirements for this software, and then we're going to try to think of how we're going to be able to address each one of these. The first requirement that I have in mind is performance. And we will go into a bit more detail of what this is exactly. The second one is I want the software we build to be lightweight. And the third one is going to be essentially a simple API for the user. So when we talk about performance, this could mean a lot of things. So what do I mean exactly by performance? Let's think in terms of number of entities that this framework will support. So we're going to say we want to be able to support 1 million entities. This can be our goal. What this means more specifically is mostly about fast iteration. We want to be able to iterate over a lot of entities quickly. We want to have, what we're going to be doing a lot as well is accessing entities. So we want to be able to access an entity in linear time, so in peak of 1. Sorry, no, not in linear time, in constant time. And we want to, we want the creation and deletion of entities not to be slow, but we don't need it to be in constant time. So I'm going to write something like creation and deletion of entities should be essentially inferior, like less than linear time, right? It shouldn't be a big O of n to create and delete an entity. And something else that I'm going to write down here, even though it's not really a requirement, but I just want to specify that I'm not going to care much about memory usage. So memory is no concern. And this is important because the way I'm going to address this requirements and the way I'm going to design this solution is based around the fact that I'm not concerned about memory. We're going to use this as a trade-off. This solution is going to use a lot of memory. And that's the reason why it's going to be pretty fast. We want it to be lightweight. Let's just say that I want to have less than 1,000 lines of code. Simply because this is a small project, and yeah, I want it to be easy to maintain. If we wanted something really big and like very, very performant, you could just use ENTT. That would be your best way to go at it. This is still going to be performant. This is used in my game engine, but it's lightweight. And then simple API, essentially, we're going to try to stick to ENTT API. We're going to use it as a model, and we're not going to be very original in that regard. But it's very simple. It's pretty user friendly. So why not just reuse it? All right. So these are our requirements. Now, with these in mind, especially the performance one, here is the architecture that I have in mind to achieve them. So first, let's define what entity, component, and system will be in our API. So an entity will be just an ID, right? It'll just be an identifier, an integer, if you want, just a number, and this ID will be what ties components together, right? So yeah, that won't be really an entity. An entity is just a bag of components, and it's just literally an ID. Now, a component will be a struct. Essentially, it's going to be a bag of data. So the user can define their own components, of course. So they create a struct, and that's all there is. There's not going to be any inheritance. I'll explain why later when we talk about components. Or actually, I can explain why quickly here. We're not going to have components that inherit a component class, because in terms of memory usage, this means that the memory allocated for each component would be much larger. Well, not necessarily much larger, but larger. Well, actually, yeah, we need to be much larger. It would need to be the superset of all possible types of components. So instead of having each component be lightweight, it would be as big as all of your components pulled together. And then finally, system. We're not really going to have systems in this framework. So I'm going to cross it. We're going to have iterators. We're going to basically give a way for the user to iterate over entities that have a specific component, or entities that have a combination of specific components. And then the user will build their own systems that use these iterators. So these are the main concepts. So as you can see, the components are mostly data. This doesn't mean the user cannot attach methods to it. It's okay. It's not encouraged by this design, but from the point of view of the framework, it won't make any difference. So we will have a class that we're going to call entity store. And this is going to be essentially the main API for our software. The thing that users interact with most of the time, all the time actually. So there's going to be a class. The user can instantiate it, and the entity store will contain a bunch of public methods. It's going to contain methods to create and delete an entity. Okay, it's going to contain a method to add and remove components from an entity. It's going to have a method that checks if an entity exists, that checks if an entity has a component, and so I'm going to call it exists, has component, and it's going to provide you iterators. Okay, so that's the public facing part. Now, under the hood, what it will do is that it will contain a system that manages the allocation of entity IDs, which will basically allocate and deallocate entity IDs when you create and delete entities. Because remember that entities are just IDs. So I'm going to call this the entity ID allocator. Right. So yeah, it will contain one of these. And use it under the hood to manage the entity ID allocation. And then it will contain a vector of what I will call a component store. So it's going to contain several component stores. Show them quickly. And each one of these will be basically a data structure around an array of components. Okay? Each one of these will correspond to a specific component type that has been defined by the user. For example, if there is a transform component, this first one, we could think about it as the transform component store. Then each one of them, like this, corresponds to a specific type of component. These will contain an array of components inside, okay, and there will be what manages reading into this array, adding new elements, removing elements, etc. Now, here is the trick that I will use to make this system performant. This entity ID, it will simply be the index to a component in the components array. So when you're dealing, for example, with entity number 5, and you want to get its transform component, you simply go to index number 5 in this component array. So that's the main trick that I'm going to use. It has advantages and disadvantages. The disadvantage is that it's going to use a lot of memory. But let's talk about the component store in more details. So as I mentioned, each component store is tied to a specific type of component, and it contains an array of components, right? But it needs to contain a bit more than just the components. Why? Because when an entity is created, an ID is allocated, right? And when the entity does not have any components, and when it's created, the entity does not have any components yet, right? But by design, this ID will still correspond to a component in this array. So let's represent the array here. From the beginning, it exists. So when I create entity number 1, so let's say that I create entity number 5, corresponds to this element in the array, but it doesn't have a component yet. So how do we handle this? What I'm going to do is that I'm going to store the component in this array. So this corresponds to a component, but I'm also going to store an array, a Boolean that I'm going to call exists, which is initialized to 0 everywhere, which means that when we create entity number 5, we don't have anything to do in the component store. It doesn't have a component yet, which is indicated by the Boolean exists being set to 0 for this entity. And then when we create a component, what we have to do really is to split this Boolean from 0 to 1. So what we will do is we're going to have a new struct that we're going to call a component wrapper. Call it comp wrapper. And this contains the Boolean. That means that the component exists or not, and then the component, which is whatever the component type is. So this is going to be an array of these component wrappers, not directly an array of components. Also, these arrays are going to have a predetermined size. And we're going to hard code it somewhere with a value like 1 million. And so that's why I mentioned we are going to use memory as a trade-off. This system will be fairly costly in memory by pre-allocating the maximum number of entities. It will be the same as if you had 1 million entities in your game at all times. And at the end of the series, I will discuss ways that we can mitigate this if it becomes a problem for your game. Now, as it stands, we're going to run into a fragmentation problem. Let me illustrate this with some drawings. So this is where we'll see if I can use the features of my tablet very easily. So we're looking at an array of components here, or component wrappers. Let me draw it really quick. So this is our array. Let's say that the first element is the Boolean, whether it exists or not, and the second element is the component data. At the beginning of the program, this exists boolean is set to 0 everywhere, which means that no component exists. And the component could be anything, really. We're going to say that this is memory, but we've not set it, so it could contain anything. It doesn't really matter for us. So what happens when you create an entity? So here I'm going to create entity 0. Okay. Let's see if I can copy and paste this thing easily. Beautiful. Let's paste it here. Yeah, okay, that's pretty smooth. So basically, this is exactly what happens actually, and nothing happens. You create entity 0, and here is the component that corresponds to it. It does not exist because this entity does not have a component yet. Now we're going to add a component. And what happens is basically, I've already explained it, but just to make it a bit clearer, let's add it to the drawing. We are just going to flip this boolean here from 0 to 1. Okay? And actually, we're also probably going to initialize the memory with something, probably either the component's default values, or we can pass some values to initialize. So I'm going to call this C0. So this is what happens when you add a component. Now you do this for a while. After some time, your program will look like this. For a while, you're going to have created a bunch of entities, and there is some associated data with them. What happens when you delete an entity? Say we delete entity number 2. What happens is that you just flip the boolean to 0, and you don't even need to do anything about the component memory, because it doesn't matter. We're always going to check whether a component exists or not before we try to access its memory. So you don't have anything to do. However, you repeat this a lot of times, and eventually you're going to get to a situation where your memory is going to be what I will call fragmented, in that this table of booleans will start looking like Swiss cheese, right? It's going to have a bunch of holes and zeros and ones everywhere. And so it's going to be a little bit of a problem in that when you iterate over components, you're going to have to iterate over a lot of components that do not actually exist before you reach the maximum number. So we can easily keep track of what is the maximum entity ID. Let's say it's this one. And when I want to iterate over these components, I have to go through this component, which is 0, so I can skip it. Then I get to this one, then I get to this one, then I get to this one. So I'm going to have to iterate over 4 components when there is only really 2 that exists, right? So that's the problem that I call fragmentation. And we're going to mitigate it by just being mindful about how we allocate new entity IDs. It's not going to solve the problem completely, but it's going to just mitigate it a bit. Essentially, when we create a new entity, we want to make sure that we pick an entity ID as low as possible. And essentially, this means we're going to reallocate an entity ID that has been deleted instead of allocating a new one. For example, in this table, instead of picking an entity ID which is just the previous maximum plus 1, which would be this one, we're going to instead reallocate entity ID 0, because this entity does not exist anymore. Now, there is a big issue with this design, but I'm going to leave it as an exercise for you to figure out, figure out what the problem is and how you would fix it. So feel free to write this in the comments if you know what I'm talking about. Okay, so this kind of like smart allocation of entity ID is going to be the job of the entity ID allocator, this piece here. Okay, and I'm going to go into this into more detail in the next video. In the next video, we're actually going to architect specifically this piece, and we're going to actually write the code. We're going to code it together. Now, the two pieces of this architecture that are left are the iterators. I don't know why I came back here. So we could provide the user with a simple iterator to the array of components, but they would then have to triage themselves between components that exist and the one that don't by looking at the Boolean. This is an implementation detail of our framework, really. We do not want to expose this to the user. This would be extremely messy. So what we will do is going to write our own iterators over this array that checks the Booleans and skips the components that do not exist. So the user will never be aware that we have this Boolean in our system. All that's going to happen from the point of view of the user is that it's just going to be iterating over components that do exist. So I think that's about it for the overall architecture. So what's the plan for the future videos? So this was essentially video number 1 of the series, which I call architecture. The previous one was just a high-level introduction, so you can label it as number 0. Next video is going to be about the entity ID allocator. We're going to be essentially writing it. Well, simply writing the C++ code for it. Next video is going to be a little bit of a parenthesis. It's going to be tests. We're going to write some unit tests and maybe performance tests, or maybe I'll keep that for more towards the end of the series. But it's going to be extremely important. There's a saying that code that is not tested is code that is broken. If you don't have anything to test what you're doing, you don't really know if you have bugs, and you will have bugs because that's the way you write code, right? You write bugs, then you check if everything works, and then you debug. So yeah, we're going to be writing unit tests. The performance tests are going to be very important as well. We want to make sure that we can iterate over all of the entities extremely fast, because that's the aim of this project, to have a performance component system at the end, and we wouldn't know if we didn't have this. Then we're going to look at writing the entity store, but the entity store is not going to be much. It's going to be mostly an interface, but we're also going to be writing the component stores. And finally, or is it finally, it's probably going to be 2 videos, but we're going to be writing the iterators. And I put them in plural because we're actually going to have 2 types of iterators. We're going to have one that iterates over entities that contain a single component, and we're going to have one that iterates over entities that contain several components. And yeah, so that's the plan. If you're interested in this series, make sure that you like and subscribe. And the next video will be the first live coding, so I'll see you then.